Hello, everyone, the citizens of the Paradise City. My name is Yang Wang. I'm the Chief Technology Officer of Global Solution Incorporated. During my leisure time, I'm also an assistant professor in the Department of Chemical, Environmental Materials Engineering at the University of Miami. So today, I want to hear about your thoughts regarding whether the Paradise City or even the United States should keep the biofuel incentive program. So biofuel is treated as a promising solution for tackling with the global climate change. So why is that? Right. So what are the processes or what are the projects that have been developed around the biofuel, and why is that important? And why should we rethink the usage or the development of the biofuel in the United States? So let's start from the climate change. So as we know, climate change, or initially known as the global warming, is because of the greenhouse gas species. And among all the different types of greenhouse gas species, carbon dioxide is known as the major greenhouse gas species. And here, what is showing is the time series of the global carbon dioxide concentration. And the carbon dioxide concentration here is actually measured at the Mauna Loa Observatory in Hawaii. This is trying to avoid the impact of the local emission, for example, emitted from the tailpipe or from the industry. And what people measure at the Mauna Loa Observatory near Hawaii can represent the average carbon dioxide concentration that's existing in our Earth. And as you can see, starting from around 1955 to all the way here in 2025, and actually right now the record is ending in January 17th, you can see that the carbon dioxide concentration has increased from around 315 all the way up to around 420. And the carbon dioxide concentration has almost increased by 30%. And what's more important about carbon dioxide, or the reason why we regard carbon dioxide as a greenhouse gas species, is because the carbon dioxide molecule is very effective in absorbing the radiation with the wavelengths in the micrometer range. All right, so this is showing the micrometer range. Right. So also we know that radiation in the micrometer range is also called a microwave, which is existing in the form of heat. And that's why we use microwave to heat up water, heat up the food, right? Because they can provide heat. And what this means is that the carbon dioxide molecules can absorb heat that's emitted by the sun and also emitted by the earth, right? Because we know that sun warms up the earth, and the earth will also reflect radiation, this warmth, back to the universe. And carbon dioxide molecules will act as a blanket that trap the heat surrounding the earth and causing this global warming effect. And of course, warming doesn't necessarily mean that we're going to endure the warming everywhere on the earth. And that's why it's important to monitor the average temperature that's on the earth and also compare that against the baseline temperature. Here, this is showing you the average temperature anomaly that's measured on our earth everywhere. And as you can see, starting from around 1900, right, all the way to now, we're seeing an increase of the temperature anomaly, which is indeed showing that the global temperature has been warming up, and which is likely due to the greenhouse gas species. And as we know, the global warming can exist in different forms. And now people are talking about climate change. And climate change will probably link to more severe weather, right? So like the hurricanes, more wildfires, flooding, hotter temperature in certain region, and also the melting of the icebergs. So that will lead to global sea level rise, and also more arid or the dry conditions in certain ranges, which will affect the agriculture. Okay, so then the question is, where does the carbon dioxide come from? Okay, if we know where they're coming from, we can probably try to find some solutions to contain the carbon dioxide concentration. So here it shows you the global carbon budget. Okay, so here this is basically showing the carbon dioxide or any type of the carbon in the form of the carbon mass. Okay, so here it's also showing you carbon in gigatons, gigaton GT, which is basically 10 to the 9th of tons. Okay, and we know that 1 ton is 10 to the 3 kilograms. So here, this is showing you the major reservoirs. For example, atmosphere, ocean, soil, fossil fuels, and then permafrost. And then these lines here, these arrows here, represents the sources and sinks of carbon dioxide in our atmosphere. So as you can see, in terms of the sinks, there can be ocean carbon uptake because carbon dioxide can get dissolved in the ocean, and we have a vast area of ocean on Earth. Okay, and also the forest over the land can go through the photosynthesis, and this can also help us reduce the carbon dioxide concentration in the atmosphere. So these are regarded as the sinks. And regarding sources, one of them is the land use change emissions. What that means is that if we convert our forests for agricultural use, which is happening everywhere because we have to feed people first. So if we do that, then originally the carbon can be fixed in these forests because they can be used to grow more organics, right? To make larger stems or grow more leaves on the trees. So you can fix more carbon. But by converting forests into farmlands, what happens is that instead of growing these carbon onto the plants, now we're growing these carbons onto the crops. And we know that we have to harvest crops. So after the harvest, the leaf or stems or the crop residue will be left on the field, either by burning, or the microorganisms will also consume these organics. So basically, the carbon that's stored in these crops are released back into the atmosphere. And if you compare that against the forests, and forests exist as a net sink of carbon. So because of the change of the land use, we're actually producing carbon dioxide into the atmosphere, and that's regarded as a source. But if you compare all of these source and sinks, you see that the fossil fuel emission is a major, or I would say a dominant source of carbon dioxide. Right? If you compare the value, this is 9.9, 1.8, 3.1, and 2.6. You can see that almost half of the fossil fuel emitted carbon is getting accumulated in the atmosphere. And that's the main factor that's driving the continuous increase of carbon dioxide on our Earth. And further, you can see some features of the carbon dioxide concentration. For example, the zigzag, this is related to the season. Right? So each year you have the increase and decrease. We know if it's during the winter season, then basically you're going to have more carbon dioxide emitted to the atmosphere, mainly because you have a reduced photosynthesis. While during the summertime, when you have more photosynthesis, the carbon dioxide concentration will decrease. So now we know the major source of carbon dioxide. Then the question is, well, to control the carbon dioxide or to control the greenhouse gas species, what can we do? Right? We know that fossil fuel is a major contributor, so why don't we control the fossil fuel? It turns out that right now it's very difficult to reduce the carbon dioxide or to reduce the fossil fuel consumption. So here this shows you the global energy portfolio, which is basically showing you how our energy is being generated. So globally, every year we generate around 620 exajoule. So exajoule means 10 to the 18th joule, right, which is a large number. And you can see that for these energy generated, the fossil fuel actually represents more than 80% of the total energy generated, right? We know that fossil fuel include coal, natural gas, right, and also oil. And because of that, as you can imagine, it's very difficult to gradually reduce these or even to erase these or completely get rid of these. Of course, there are efforts regarding renewable energies or non-carbon sources that can generate energy. For example, there can be hydro energy, nuclear energy. Of course, there are some safety concerns about the nuclear energy, right? And also there is a larger, I would say a growing fraction of the renewable energy that's joining this energy portfolio. But still, will be quite challenging for us to immediately reduce the fossil fuel consumption. And then as we have shown earlier, right, so this is showing you the United States annual fossil fuel consumption. And you can see this is the data and all the way until 2020. And you can see, I mean, for the United States, definitely the consumption of coal has been decreasing, but the consumption of the petroleum and also the natural gas has been increasing over these 40 years. And then we can also divide the energy consumption by factors, or by sectors. So if we can identify the major sector, the industrial sector that's consuming these fossil fuel, maybe we can try to gradually reduce the fossil fuel consumption in those areas. And you can see that in terms of the sectors, right, transportation is a major sector that uses these fossil fuels, right? And also industrial fuel, industrial non-fuel, residential, commercial, and electric power. So of course we know that electric power nowadays still we rely on coal or natural gas to generate electricity because they are very easy to transport. And they can also lead to high efficiency. But you can see, well, the major sector that's consuming the fossil fuel is transportation. So then what about we reduce the consumption or gradually phase out the fossil fuel that's consumed from the transportation? And we know that the gasoline we use every day by our cars, a lot of them are also imported, right? And due to the political situations over the years, the United States or all the countries also want to reduce the reliance on the imported petroleum. So what about we find some renewable source of the fuel that can reduce the reliance or reduce the consumption of the fossil fuel in the transportation sector? Can we do that? Okay, so if we think about our mother nature, right, we know that the trees or the green leaves are actually very effective in converting the solar energy into fuels or into actual, let's say, hydrocarbons or organics, right? They use photosynthesis, you have solar radiation, you have carbon dioxide and water, then you can turn them into these organic mass. So then the idea is, what about, I mean, in the most direct way, what about we just cover all the land mass by these trees or by these biospecies or these plants, and then every year we just take a fraction of these plants as fuels. Even a small fraction can generate a large amount of energy that could basically be used to replace these traditional fuels. Well, at the same time, as you imagine, these trees will also grow by themselves. Okay, so if the speed for their growth or the rate for their growth is higher than the rate of our consumption, then we can lead to a sustainable situation, right? Where the energy that we use from these biological species are going to be renewable. And at the same time, these trees or these plants can absorb carbon dioxide in the atmosphere. So basically, we can reduce carbon dioxide concentration from this process, but at the same time, satisfy our demand for energy. Okay, so this is the idea for the biofuel. So the biofuel basically wants to grow crops or grow different types of plants, right? So a lot of times we would actually grow corn, right? And then we convert the corns or convert these organic matter into fuel, and we call them as biofuel. And further, in industry or in transportation sector, we can burn these biofuel, right? We can add them into our gasoline, burn them, and of course, the combustion of the biofuel, well, we can generate energy that can drive our cars. At the same time, they're going to emit carbon dioxide. But these extra or these emitted carbon dioxide can be again absorbed by the crop. And further, you have this entire cycle of carbon dioxide being generated and then fixed and converted to biofuel. So basically, in this way, we can achieve this renewable feature of this fuel. So that's why the biofuel is regarded as a renewable fuel. Okay, so then the problem is, well, can we support this huge demand of energy? So here this is showing you a global picture of the electricity, right? So how light looks like, or how nightlife looks like globally, right? The brighter the region, the more energy consumption, right? This is talking about the the light overnight, right? So can we support this energy demand by using these plants, or more specifically by using the crops? So here, this is showing you the agriculture activity globally. So can we use, for example, growing crops or growing forests to generate the fuel that we need to power our daily life? Okay, so can biofuel be able to sustain our energy consumption? So then here comes the definition of the biofuel. So what are biofuel? So there are, of course, different definition, right? Overall, if you look up the Oxford Energy Dictionary, so it's a very short definition. Basically, biofuel is a fuel that's derived directly from the living matter. Okay, for example, trees or crops, corns, for example, corn, soybean, and so on. If you search for the definition of biofuel on Wikipedia, so the biofuel is a fuel that's produced over a short time span from biomass rather than by the very slow natural process involved in the formation of the fossil fuels such as oil. So there's a direct difference between the biofuel and fossil fuel. Fossil fuel is going to take a long time, right? You cannot really renewably or sustainably generate the fossil fuels in a short time. And instead, biofuel can be used to can be generated by just using these crops or plants over a relatively shorter time, hypothetically, right, under the ideal situation. And then we can produce the fuel and also produce the energy that we need. And more specifically, in the United States, a lot of the research regarding biofuel, or a lot of the, I would say, the regulation regarding the biofuel is assisted by the Department of Energy. So Department of Energy has a huge program related to biofuels, both on research and also the policy-wise, the reinforcement side. So the Department of Energy, or the DOE, also has a definition of biofuel. So the biofuels are basically the liquid fuels produced from renewable biological sources, including plants and algae. Okay, so further we constrain the definition of the biofuels into liquid fuels, because there can also be gaseous fuels like natural gas. But a lot of times we'll also liquidize the natural gas, right? So because of that, we can still consider the natural gas or methane as a biofuel, because we can turn them into liquids. Okay, so then basically the biofuel, as you can imagine, is not only about burning trees. So here we were talking about an example of growing forests and then consume the energy that's generated from the forest. It's not about burning woods, because our cars cannot burn woods, right? Instead, our cars likes liquid fuel. So basically, we're trying to convert the wood or the plant into liquid fuel through these factories, chemical plants, right? A lot of times, people actually use the corns and turn them into fuels. For example, bioethanol. And then we can use these bioethanol, or use different types of the biofuels in our transportation sector or in other industrial sectors. So here it's talking about plants, and there are newer versions, newer generations of the biofuel that's generated from the algae. Okay, and in terms of the biofuels, it is really a relatively recent thing, or recent item that started to attract people's attention. So here, this is the basically the frequency of the term that's being used by the books, and this is directly search this on Google, right? So you can see that the term of the biofuel really hasn't been used much, and this term, or this use of the biofuel, really started from 1970s. So we know that near the 1970s, that's the establishment of the EPA. So the biofuel was initially driven by the fact that people want to protect air quality. And later on, we further have this increase or over the 2000s, because people realize that, well, by developing biofuels, we can reduce the reliance of the petroleum or of the oil that we import from the foreign countries, right? So we can sustain our consumption of the fuel and get this independence of the fuel consumption. And at the same time, later on, people realize that, well, by using biofuel, by producing biofuel, we can also reduce the carbon dioxide concentration, because eventually, if we can achieve this sustainable production of the biofuel, right? So we could eventually achieve the goal of reducing the carbon dioxide in our atmosphere. And of course, recently there have been decreasing of these terms because there are more areas that can be developed. But overall, you can see that the discussion of the biofuel really started from the year of around the 1970s. So right now, there are different generations of the biofuels, and different generations are basically based on the feedstock for producing the biofuel. The first generation of the biofuel, they use the energy crops, for example, the corn or sugarcane, right? So for these energy crops, there's a lot of sugar inside or glucose inside. Or starch, right? We know that for the starch, we can use some chemical processes and then turn them into first glucose, and then further through the fermentation, we can turn them into alcohol. Similar to the process of people making alcohol out of these energy crops. Okay, and further, well, the usage of the crops for making the biofuel actually caused some controversies. We will talk about that later on in this class. And later on, people realize that, well, if we don't use the energy crops, what about we just use the typical forest materials, right? So, for example, the leaves or the stems of the crops or of the trees or forest in the forests. Okay, so we categorize those feedstocks as the lignocellulosic biomass. So a lot of times, for this biomass, they are made of the lignin, which is difficult to be digested or to be reacted and form into biofuel. Okay, so people have to do a lot of design of the bacteria that can, or the chemical processes to convert these materials into the biofuel. So that's why it's regarded to be a little bit more challenging compared to the energy crops. Okay, so examples of the lignocellulosic biomass include agricultural residues, forest waste, and so on. And later on, there is this third generation of the feedstock, which mainly include algae and microbial biomass, right? So people realize that the algae can actually grow very fast in their mass, and they're very effective in absorbing carbon dioxide, so they can populate very quickly. And due to the simple structure of the algae, right? So we basically, you can treat that as an energy crop. So you grow a large amount of algae, and then you can find the chemical process and then to turn this algae into biofuels, or these microbial biomass into biofuels. Okay, so that's regarded as the third generation. And of course, the fourth generation are waste streams. For example, the waste that we directly toss and then store at the landfill. So there can be some chemical processes that can extract the fuel out of the waste directly. As you can imagine, the difficulty to convert these feedstocks into biofuels is getting more and more challenging as we move up in its generations. And in the ideal situation, of course, you want the fourth generation, right? So basically, this is a recycled energy form that whatever waste we generate can turn back into energy. And at the same time, since this process will, for example, will likely reduce the carbon dioxide emission, we can also solve the problem of the climate change. So, of course, these are the ideal situations. So what really happens, or chemically, what is happening in converting these molecules or the biological molecules into biofuels? Okay, so here I'm showing you some molecules. So for the plant species, now let's talk about the energy crops or lignocellulosic biomass, or at least the first and second generations, which rely on the plants to form the bioenergy or the biofuel. So here, these are the general type of molecules that are existing in the plants, right? So you can see that they are smaller molecules, hydrocarbons. A lot of them contain oxygen. We cannot really use these fuels to generate energy directly because a lot of them are gaseous, right? And at the same time, these molecules, because they have a lot of oxygen inside, they cannot really contain a lot of energy. They cannot generate a lot of heat when we combust them. And in terms of the fuels, for example, the gasoline, right? So you can see that they have these long chain-like molecule. So each dot here represents a hydrocarbon, right? So CH group. So basically you have C here and then you have hydrogen here, right? So you don't see much oxygen here, right? And of course, as you make the carbon longer, if you don't have oxygen, it just means that it's going to have a higher heating value. You're going to generate a higher temperature during the combustion. And the higher the temperature, the higher the power, and also the higher the efficiency for the combustion. You can drive your car for longer distance, right, and at a faster speed. So the problem is, how do we convert these molecules that we see from here on the left-hand side into these long chain-like molecules? I probably have mentioned this earlier, like we can use some bacteria, but here I'm also showing you some molecules. Okay, so you can see that these molecules are actually quite similar to the molecules we see here. So what are these molecules? These are actually the molecules that's existing in everyone's body. This is just fat. Okay, so if you think about what's happening in the human body, if we have extra energy that's ingested into our body, we can actually convert these molecules into these long chain like hydrocarbon molecules. And further, theoretically, we can use these long chain like hydrocarbon molecules for biomass or for manufacturing the biofuel. And we know that, well, these genes do not only exist in human. And actually, a lot of these genes are existing in the microorganisms, like the bacteria. So if we can find the bacteria, so here this is showing you some pictures of the E. coli, right? So which is type of the bacteria. So if we can culture some bacteria that can convert these tiny molecules into bigger molecules, then basically we can ask them to work for us. That we can first grow some plants or crops, and then we can, of course, grind the crops to make them smaller pieces, and then we can add these bacteria in. And while these bacteria enjoy their food, they produce these long-chain biofuels. And further, we can produce the biofuel or use the biofuel to drive the demand or to satisfy the demand of fossil fuel in different energy sectors, especially in transportation. Okay, so then the problem is, well, how do we make different types of biofuels? So there are several types of chemical reactions. I know that you probably have different backgrounds in chemistry. So here I will just quickly or briefly introduce these detailed biofuel production technologies. So the most simple one, or the basic one, is called the fermentation. This is the process that we make wine, okay, or make alcohol, which can be dated back to hundreds or thousands of years ago. So what happens is that we just add bacteria, we can add some sugar. So sugar can be coming from corn or from starch. And then under the condition where you don't have oxygen, you go through the fermentation, you're going to have produce alcohol. Alcohol is made of ethanol, right? So we call this fraction of ethanol as a bioethanol. At the same time, you can produce carbon dioxide and heat. And here it actually shows you the detailed process of producing the ethanol. So the sugar, the major composition is glucose, and then you can go through this first step and the second step. This is a biological process. And then eventually you can form ethanol. Okay, so I have to say that the fermentation is the most basic process or the most simple way to produce biofuel out of the plant species. Okay, and then as you can see, well, the ethanol is not a long chain molecule, which means that it cannot produce a high energy level. or a large amount of heat during the combustion. So then the problem is, well, we can't really use these ethanol to power our heavy trucks or even to power our airplanes because it cannot produce a high energy. So that's why there's thoughts about producing biodiesel. So biodiesel are basically the long chain hydrocarbons, and then the chemical process that's involving in this process is called the transesterification. Okay, so the transesterification is basically replacing the carbon species that's existing at these longer chains by any hydrocarbon, which is the R prime here. So basically, through this chemical reaction, you can replace this single carbon by more hydrocarbons. So you will create a longer chain, right? So you can see the R can be any hydrocarbon, which means that it can be any length, right? This side can be any length. Originally, it's just a short chain reactant, and then after this transesterification, you can have a longer chain of the biomolecule or the organic molecule that you can make molecules similar to these ones over here. So because of that, you can enhance the heating value and also the energy out of the combustion for these molecules. Okay, so there's also a simple way of producing biogas. So the biogas is just using the anaerobic digestion. Anaerobic digestion is a process that you don't have much of you don't have oxygen involved in the process, which basically you can convert these sugar into methane. Okay, so for example, if you go to swamps, we're very close to the Everglades. So there's actually a large amount of organics existing in the swamps. And overnight, when there's no oxygen, overnight when there's no photosynthesis, if there's no photosynthesis, then in the water there's going to be less amount of oxygen. Under that situation, you can basically go through, or the anaerobic digestion will happen, and then you can produce the methane out of it. And we also call these methane as the marsh gas, right? So there are quite a lot of documentaries or videos showing that how you can collect the marsh gas, and then you can use that during your camping. Okay, so this is related to the production of the biogas, and we can also go through some additional chemical engineering processes, for example, the gasification and pyrolysis. So basically what happens here is that instead of directly using the biomass, we can enclose the biomass into a reactor. And then under the situation where we don't have oxygen, you just warm up these species, and then some of the volatile species from the biomass is going to get emitted into the gas stream. Right? You can get the volatiles, and further these volatiles can react, and eventually you can form these long chain hydrocarbons. Okay, so these are different ways to produce the biofuels. Of course, as we have mentioned, biofuel has some advantages. At least according to our ideal situation, it is a sustainable fuel, right? Renewable fuel. And one example is the production of the biofuel from the corn, right? So we can produce a large amount of bioethanol from the corn industry. So in terms of the economy aspect, right, biofuel industry has created a lot of jobs in 2023. There are close to 35,000 jobs related to the biofuel. And it also helps develop the rural area. Right? We know that there are urban areas and rural areas, and normally rural areas are, I would say, bothered by the lower income and also the less development. But because of these newer technologies of the biofuels, we can actually help develop the rural areas. So it can create jobs in different aspects, right? The agriculture, forestry, manufacturing, trade, and professional, covering all different types of jobs. And as we said, by producing the biofuel, we can also ensure the energy security. So we're less dependent on the foreign, let's say, the gasoline or the import of the liquid fuel, right? And to ensure that, well, there could be scenarios with different political situations. We can still produce biofuel out of the the agriculture activity, right? Out of these plants. So the development of the biofuel can also diversify the energy market. So right now we know that the energy market, or at least for electricity generation or the transportation, we have to rely on fossil fuel, or like energy production, we have to use hydro or nuclear or solar, right? So adding biofuel inside, it can provide us with more options of producing fuels. Okay, so in case one aspect or one source of the fuel, one way of generating fuel becomes less reliable, we can rely on these renewable fuels to produce the energy. And of course, it can also help us with the stability of the agriculture market. This basically tells the farmers that, well, for the corn, it is a reliable crop because it doesn't matter whether people like to eat corn or not like to eat corn, because we know that people may have different tastes. It could be that over several years we really like corns, we make cornbread, we boil our corn, or maybe some years that we really dislike corns. So if we only decide what to grow based on people's taste or based on culture, right? So then it's going to lead to a fluctuation of the price in the corn. But if these corn or these extra corn that we grow can turn into biofuel, then it can help us stabilize the agricultural market. Okay. And in addition to that, thinking about the impact of the biofuel on our environment, there are also some advantages that people have, or people have imagined, or people have discussed. For example, it is indeed renewable, right? Because every year we can grow the corn, it can absorb carbon dioxide, right? And then turn them into the corn, and corn can further turn into biofuel. And at the same time, basically, they can replenish, right? So every year we can grow the corn or grow these plants or these energy plants. And also there's less emission of greenhouse gas in the fuel manufacturing. So basically when we produce the biofuel, so since it's acting as a sink of carbon dioxide, so overall, although you are still burning the biofuel, you're still burning the biofuel and turn them into carbon dioxide. And actually, this amount of carbon dioxide can get absorbed through the growth of the crop. Okay, so that's why it can be considered as a renewable process. At least the overall emission of the carbon dioxide from the biofuel during the combustion process is reduced. Okay, unlike the fossil fuel, which is basically the stored of, let's say, the type of fuel that's accumulated on our Earth, right, as existing in the solid form and directly release them into carbon dioxide. There's no way to easily trap these carbon dioxide and turn them back into fossil fuel. Okay, but in this way, we can easily regrow them, right? So they can replenish naturally. So overall, the emission of the greenhouse gas species in the fuel manufacturing is lower, or the fuel combustion process is lower. And in addition to that, the biofuel that we generate from these processes also has less impact on chemical spills. And it's mainly because all of these biofuel molecules, they are safe to the microbes, right? Because they're manufactured by the microbes. So because of that, if we have a chemical spill of this biofuel, there are going to be different types of microorganisms that can decompose these biofuel. So if there are chemical spills, the impact of the biofuel on our environment is also going to be smaller, right? For example, if we accidentally spill some oil that's made by vegetable, which we use for cooking every day, we're less concerned about it because it's not a pollutant, right? Human can eat it. All different types of living organisms can eat it. Okay, so these are the advantages. But in terms of the emission, right? So I'm starting to talk about some concerns related to biofuel. I would say some concerns, some advantages as well. So we only discussed the smaller amount of emission, but what about other types of pollutants? We know that carbon dioxide is greenhouse gas species, but then during the combustion, we also generate other pollutants, right? So for example, the particulate matter or the volatile organic compounds and so on. So some of them could be harmful to human. So here there are actually several research studies summarizing the impact of the biofuel combustion. If we use them in cars, right? So use them in the transportation industry, how the biofuels might compare against the traditional fuel. So of course different cars may have different performance, but overall people want to characterize the mass of these pollutants emitted per kilometer of the distance the car drives, right? So there can be different cars, MPFI, DISI, FFV. So they just represents different types of the engines for the car. So it's also listing these different fuels, right? The base fuel is the petroleum or the gasoline that we get from the normal gas station. E10 is actually short for ethanol, 10%. Okay, so nowadays, if you go to the gas station, you will see these E10s, right? So basically, there's this regulation that for the gasoline, we have to add in 10% of the ethanol or the bioethanol that's released or that's manufactured from the biofuel energy. So they are produced from the agricultural process or these energy crops. Okay, so it turns out that if you compare the emission of these pollutants, a lot of these you can see a relatively reduced emission, right, or at least similar amount of the emission. So, but if you add in more, so for example, E10 plus R is adding more biofuel inside, or the IBU is ibutanol, right? So it's or butane. It's basically more species of the biofuel in the that's mixing with the traditional fuel, and then you start to see, at least for the hydrocarbon or carbon monoxide, they're okay, but of course it's dependent on the car, right? So in addition to carbon monoxide or hydrocarbon, there's also nitrogen oxides, nitrogen dioxides. These are regarded as the gas pollutants that can lead to acid rain. Right? The reason why we emit the nitrogen is because for these biofuels or even the fossil fuel, there is nitrogen inside, right? So this is mainly because no matter which fuel it is, originally it is a part of the organics or living organism, right? Living organism, we know, for example, human being or any animals or our protein, right? They contain nitrogen inside. So these nitrogen will exist in the fuel, and during the combustion, these nitrogen will get converted into nitrogen oxides. So you can see now, with the addition of the biofuel, you're starting to see some increase of the nitrogen oxides. So just pay attention here that when we talk about the less emission, we're mainly talking about the greenhouse gas species, right? And carbon dioxide. And also we focus that on the fuel manufacturing, that's the production of the fuel, because it will absorb carbon dioxide in the atmosphere. But later on, we will discuss how the evaluation of the greenhouse gas emission might be limited if we only talk about the fuel manufacturing. Okay, so these are the nitrogen oxides and hydrocarbons or carbon monoxides. And if you think about the emission of these more detailed organic vapors, so again, comparing against the traditional fossil fuel, depending on the cars, there may be no noticeable impacts or severe or significant increase of these pollutants. Particulate matter, which is the tiny particles that's emitted from the combustion, similar scenario, right? So by using the biofuel in our cars, we don't necessarily will see an emission of other pollutants in its usage. Right? The same thing for the PAH. This is polyaromatic hydrocarbon. Right? It's treated as a toxin that's coming out of combustion. Okay, so you can see that by adding these biofuel or mixing them with the traditional fuel, we may generate additional air pollutants, right? Not talking about the fossil fuel, or not talking about the carbon dioxide. And then the question is, well, why is it only E10? So actually nowadays, there's also E15 or E20. Okay, so the major problem for not limiting us using a higher fraction of the bioethanol is because of the engine. Okay, so our engine is designed to burn hydrocarbons or the petroleum, right? To burn the gasoline or these base fuels, right? By adding in these ethanol inside, it's going to change combustion characteristics. And as we said, the ethanol has oxygen inside, so overall the heating value or the energy that's stored in the ethanol is also lower, right? So this is going to influence how our engine performs. And if you put in too much of the ethanol inside, you may damage your engine, right? And of course, nowadays there are newer versions of the vehicles that can even drive with E85. E85 is 85% of the bioethanol, right? So basically, as technology advances, it is likely that we can push for a higher mixing ratio of these biofuels coming out of the crop production. Okay, so in addition to the ground transportation or these light duty cars, right? So we're just talking about cars here, so passenger cars or smaller cars. So what about those heavy duty cars, or those in the aviation industry? Because for those industry, they actually need to use diesel, long chain diesel. Right? We call those fuels as the kerosene. Okay, so the diesel or the biofuel that's similar to the kerosene is also called the e-kerosene. Okay, so the goal of developing these biodiesel or this e-kerosene is to help with the hard to abate transportation. So I would say for these examples, these are easy to abate transportation, right? We just mix bioethanol with the fuel. But then we can't necessarily mix ethanol with the aviation fuel. This is mainly, again, because of the energy that's stored in these fuel molecules, right? So even on that, there have been research going on to help produce these bio-kerosene or e-kerosene to help reduce the carbon dioxide emission, right? To produce these fuels from the biomass. So there are also like recent studies or the active research studies about burning biofuels, using biofuels, and then measure the emission coming out of the combustion from the aviation industry. Like here, I'm showing you a study saying that the biofuel blending actually reduced the particle emission from the aircraft engines at cruise altitudes. Okay, so there have been studies on these areas mainly because so for the aviation industry, if you emit more particles, and since these airplanes most of the time at the cruising altitude, they're in at the bottom of the stratosphere. Okay, so this is the layer of the atmosphere that's relatively calm. You don't have the turbulence in the troposphere, right? So in this layer, the problem is that if you emit a large amount of particulate matter, or we call aerosols, so they can turn into these cirrus clouds. It turns out that in the atmosphere, the existence of the cirrus cloud can lead to a net warming effect. So basically, if you emit a large amount of aerosols, you might warm our atmosphere compared to the clouds that are formed at the lower level. I think Dr. Pakita actually gave you a nice lecture regarding how the clouds can help reduce the temperature on our Earth. And then, of course, there are engineering processes to try to tackle these global warming issues. Okay, but from this study, it's showing some promising results that if we use the biofuel in aviation, we can actually reduce the particle emission coming out of the aircraft engines. So we have talked a lot about the biofuels, how it is promising overall, it reduces the carbon dioxide emission. But what is the reality? Okay, is it that promising? As you remember in the beginning, I'm asking your opinion whether we should continue to promote the biofuel or even to incentivize the biofuel production. So, what are the problems? The problem associated with the biofuel industry is that currently, in terms of the total amount of biofuel that's generated, 85% of the biofuel is only limited to bioethanol. And then in terms of the bioethanol, it turns out that including both the industrial ethanol or the bioethanol, 90% of the total ethanol in the United States is made from corn. So you can see that basically we're using a large amount of corn or growing a large amount of corn to produce the ethanol, and the ethanol occupies, I would say, the vast majority of the biofuel that we use nowadays. Okay, and then currently in the United States, 40% of the corn that's produced is used in making the bioethanol, and of course the rest, 60%, is used for food that we eat, and also for the animals, right? In the meat industry, we have to feed our stocks, feed our chicken, cows, right, to produce meat or eggs. Okay, so you can see that the entire biofuel industry is heavily relying on corns, okay, to produce a bioethanol. And it's just a single type of the biofuel that's generated. We talked about different versions or different generations of the biofuels on our earlier slide, generation 1, 2, 3, 4, and nowadays we're still focusing or still staying in the first generation. Okay, so then what is the problem? Okay, if we're growing corns for bioethanol, right? So why is that a big deal? So it turns out that growing corn is taking a large amount of the usable agricultural land or usable land. Okay, so we're talking about deforestation, land use change. We're turning our forests, turning our grasslands into the croplands. So this is showing you the crop residue biomass. This is basically a the crop residue biomass is related to the mass of the total crop that's grown over the area. Okay, so you can see that there's a large amount of land in the Midwest that has the dark color, right? So it can generate a large amount of biomass, and it's actually related to the growing of the corn. Okay, so we're turning these lands into cornfields to just produce the corn, and then 40% of the corn that will grow in this area is being used to produce bioethanol. Okay, so then it's a problem of it's a problem related to whether we should do that. So there has been a very sophisticated, I would say, argument or a debate related to the food versus fuel. Okay, and of course you can also search for some videos or search for some documentaries and then the write-ups regarding the food versus fuel debate. So basically, what happens is that we would think that growing corn is helpful, growing corn and then turning them into biofuel is helpful for us to produce more energy, right? And then to help us reduce the carbon emission, also to make us more independent of the foreign import of the fuel or the gasoline or the oil, right? But the thing is that by using them in the biofuel industry, it will likely drive up the food price. And of course, if the price is higher, then poorer people cannot use the fuel or cannot enjoy the corn anymore. And at the same time, the price of the corn is also affecting the meat industry because we rely on corn to feed the animals, right? So it turns into a debate between the crop or the agriculture industry and the meat industry. And in addition to that, there's a lot of dilemma involved, right? So let's discuss this in our class next Wednesday, right? So just tell me your thought regarding whether we should prefer food or put out food as the first priority, or fuel as the first priority, or if there's a way to balance the food of fuel demand. Okay. So in addition to that, there are also additional controversies about the biofuel, or especially about growing corn in the United States. So first, it's related to the land use and the deforestation, and we talked about that earlier. By turning the natural land, forests or grassland, into cornfields, we actually emit more carbon dioxide into the atmosphere. And in addition to that, agriculture, we know that it consumes a large amount of water. And in addition to that, we put fertilizers, right? We put pesticides. They can cause environmental pollution. And in addition, even the fundamental advantage of the greenhouse gas reduction might be questionable, because now we're only talking about carbon dioxide reduction during the growth of the plant. But to transport the seed, or to transport the corn, and also to transport the fertilizers, and basically the fuel consumption during the transportation and additional chemical processing might actually produce more carbon dioxide in there. And I would encourage you to check up some numbers related to the greenhouse gas emission from the production of the bioethanol. And overall, by changing or by turning the corn into bioethanol, it's also related to the higher production cost. So overall, if you compare the price of the bioethanol to the price of the petroleum, you will see that, or to the price of the gasoline, you'll see that the price of the gasoline is actually still cheaper compared to the bioethanol. And as we mentioned earlier, there are engine compatibility issues and energy density, right? We said that bioethanol contains oxygen in there, right? So the energy density is lower. And in addition to that, we mentioned that, well, if we promote or incentivize the growth of the corn, right, to produce bioethanol, we may also have some issues with the biodiversity. So it's related to monoculture. So why can't we grow other types of crops, right? So overall, it's bad for the soil health, because if you just keep growing one type of plants, and then without alternating the plants, then the soil will become deficient in certain type of nutrients. And then you have to add in more fertilizers, so on and so forth. So overall, it has this chain of issues related to the environment and also related to our ecosystem. So what this basically means is that we need to do a more comprehensive analysis of the carbon emission or the pollutant emission associated with the growing of the corns, or this entire biofuel industry. So that's why this special type of analysis called life cycle analysis is needed. So the life cycle analysis will consider all the different steps during the entire process of the biofuel production. Okay, starting from growing the crops, the purchasing of the seeds, right? So irrigation, adding fertilizers, and then to transport the grown corns, how do you deal with the agricultural crop waste, right? Whether you burn them or you go through landfill, and also the chemical processes that produce these bioethanol. Okay, so we need to conduct a comprehensive or life cycle analysis. So it turns out that by including the life cycle analysis, or conducting this life cycle analysis, it turns out that if you just consider the corn ethanol, the bioethanol, it turns out that we're actually paying more compared to just using the gasoline, which is a baseline here. Of course, if you're talking about the second generation of the biofuel by using cellulose, right? We said that by using forest residues like the leaves or stems, that can reduce the overall cost. So this is showing the cost, but more specifically, it's related to the cost of the greenhouse gas emission and particularly matter emission. Okay, so you can see that if you just simply grow the corns to produce the biofuel, actually you're emitting more carbon dioxide in the atmosphere. And in addition to that, there are studies based on the economic analysis showing that when we grow the corn, and because of the biofuel industry, it's actually driving the corn price up. Okay, so here are some assumptions that if we do the business as usual without incentivizing the biofuel industry, incentivizing the bioethanol, we actually could have observed a more steady price of the corn. Okay, and then this is showing the corn price and also showing the different scenarios or the let's say the other types of the or the other different models, basically using different models to predict the impact of biofuel industry on the price of the corn. Okay, and in addition to that, we said that the Midwest is the major area where we grow corns, right? So basically, it's showing that because of the growth of the corns, you're actually emitting more carbon dioxide associated with the entire life cycle analysis. You add more fertilizers, nitrogen applied, nitrogen oxide, nitrogen oxides are getting emitted. There's also nitrate that's leached into the natural water system that can cause some nutrition problems, right? It can lead to the overgrowth of the algae species because we put in more fertilizer in the water. So we're adding more phosphorus because of the fertilizer application, and then there will be issues with the soil erosion and also there's phosphorus runoff, right? So this is related to nutrition. So overall, it looks like by growing corns and then promote this bioethanol, this biofuel here, we're actually creating more environmental problems. And I think most of you probably have seen this movie, right? So this is the Interstellar. So you see that basically it's telling about the human moving to another planet, and then this is mainly because most of the plants that's existing on the Earth are going through diseases, right? And this is because the low biodiversity. And it turns out that the only crop that can grow on the earth at that time was corn, and even the corn was not growing properly when during this movie's time, right? During the time that's depicted in the movie, and that's why people have to move to different galaxies to set up civilization there. And of course, we don't want that to happen. Okay, so this is more like an extreme condition. But you see that biodiversity is indeed a huge issue, and we do not want to promote the single growth of the corn just to incentivize or just to promote the biofuel industry. And of course, there are ways to change this issue, right? There's a lot of research going on, and then in order to produce, let's say, second generation, third generation, or fourth generation of the biofuel, as we show here, right? If you can indeed produce the cellulosic ethanol, which is the second generation of the biofuel, we can actually reduce the greenhouse gas species and then carbon dioxide. But the issue is that right now, 85% of the biofuel is just corn ethanol. Okay, so basically to generate or hire more advanced biofuel types, we need advancements in biotechnology. We need to genetically modify the bacteria that we use to convert these organics into fuels, right? If we can design better bacteria, we can easily turn, let's say, the tree residue, leaves or branches to even to ethanol, right? It's still helpful. And we can also try to enhance the metabolic pathways to produce higher yields. For example, if we can grow our corn to twice of its original size without doing much or without adding much nutrition, without putting too much influence on our environment. And that's why there's a need to create this synergy between the biotechnology and chemical engineering. And if you know our department, Chemical Environmental Materials, and go to our website, you can see that there are different clusters regarding research. You see that we do air quality study, that's aerosol science technology, water quality, And then especially we have this synthetic biology, right? Synthetic biology is related to these advancements of the biotechnology that can help us produce more efficient biofuels, right? To produce these biofuels without increasing the greenhouse gas emission. So here, this is a list of policies that's related to the biofuel to incentivize the biofuel industry. So as we said, the biofuel really started in 1970s as a part of the Clean Air Act. So the goal is to reduce the mobile sources of the pollutants. And as you see earlier, indeed, by using bioethanol, we could lower some of the air pollutants from the fuel combustion. And then later on, in 1988, there's this Alternative Motor Fuel Act to provide incentives to the vehicle manufacturers that they can design better engines to accommodate the biofuel. There is this Energy Policy Act, right, to require certain governmental or federal agencies to have fleets or have vehicles, and then to build up an inventory of alternative fuel vehicles to basically accommodate the biofuel. And then in 2007, there's this Energy Independence and Security Act, so which is about increasing the supply of the renewable energy sources, more specifically on biofuels. Right. So also during that time, there is this policy of adding in 10% or mixing 10% of the bioethanol with our gasoline. So now we're using the ethanol or using the fuel in our cars where 10% of the fuel is coming from the agriculture industry. So further, there's this Energy Improvement and Extension Act providing tax credits to these alternative fuel vehicles or these better technologies. And American Recovery and Investment Act, this large amount of money and related to the renewable energy technologies. So then the question is, given these advantages and disadvantages and potential development of the biofuel, should we keep providing incentives to biofuel industry? Right? I think this is a major question we want to discuss in our next class. So given these scenarios, right, because we're sort of in this dilemma there that we have invested a large amount of money, we have created these large number of jobs. So should we keep on doing the promotion of the biofuel, or we should just stop there, or we could probably even reduce the developing of the biofuel? So what should be our pathway? We can discuss that further on in our class. And of course, there are examples that the United States or the Paradise City can learn from. So nowadays in Brazil, the biofuel makes up 25% of the transportation fuels. This is a significantly higher share compared to other nations, other countries. Okay, and this proportion is still increasing. And in Brazil, is more specifically, they're using the sugarcane to produce the biofuel or to produce the bioethanol. And also the bioethanol industry is a major biofuel sector. It leads the biofuel sector. It represents an average of 50%, 49% in terms of energy and total gasoline and ethanol consumption. So you can see that there are successful examples that United States can learn from. But the issue is that the economy doesn't work exactly the same way. And then it definitely is associated with the labor, the cost of labor, right? And also associated with the landscape or the land type, because in Brazil most of the land are more humid, right? They can grow faster, but in the United States, it's not necessarily the same way. And actually only, in terms of sugarcane, only the warmer areas can grow them, right? So we could try to learn from the others and then to consider the different scenarios and then to decide whether or not we should further provide incentives to the biofuel industry. And of course, there are future trends or emerging technologies related to the biofuels. For example, producing the next generation biofuels that we discussed earlier, right? And we can use AI or use these advanced biotechnology or AI to optimize our process design. And then even we can try to produce the biofuel or better biofuels that can create a carbon negative process, create carbon negative scenario, right? So instead of let's say still emitting carbon, we can draw this back down to negative values. We produce, let's say, profits out of this industry. Okay, so that's it for this lecture. As a summary, we covered different types, technologies, or the interdisciplinary benefits and challenges associated with the biofuel. And then also discuss the promise or the potential of the biofuel in a sustainable energy future. But right now, based on what we have, biofuel seems to have a lot of challenges for our goal of achieving a renewable source of the energy, as say, at least regarding it as a renewable source, energy source, right? So the question is, should we continue these different incentive programs related to the biofuel? So that's it for this lecture, and I look forward to seeing you all on Wednesday.